This episode of Troxel is supported by Avail. Content is more than Revit families. If it's digital, Avail can handle it. Learn more at getavail.com. Welcome to the Troxel Podcast. I'm Evan Troxel. Well, this is the last episode of 2022, and it's closing out what I would consider a pretty nice run of conversations for everyone to hear and to help elevate these topics in AEC. I thank you all so much for listening and for adding to the conversation, either through sharing the episodes with your friends and colleagues and for commenting and keeping the conversation going on social media. I'd love to hear what the standout episodes were for you personally. So let me know on Twitter. You can find me at eTroxel or on LinkedIn, or leave a comment on this episode at trxl.co/podcast. Okay, in this episode, I welcome Oliver David Krieg, who is better known as OD. OD is an expert in parametric design and robotic manufacturing in the AEC industry. As Chief Technology Officer at Intelligent City in Vancouver, Canada, he is leading the development of their mass timber technology platform for high-rise construction, combining building systems, manufacturing, and software development. This is part of the company's effort to provide urban housing as a sustainable, affordable, and livable product solution. Prior to joining Intelligent City, OD was a doctoral candidate at the Institute for Computational Design and Construction, aka ICD, at the University of Stuttgart, Germany. There, he led and participated in several international research and built projects that explore architectural potentials in timber construction. In this episode, we discuss topics at the intersection of computational design, robotic fabrication, and turnkey urban housing as a product. We begin with OD's journey from school at ICD in Germany to where he is currently at Intelligent City, the value and benefits of bottom-up as opposed to top-down initiatives, moving away from project thinking to a product company, navigating risk versus reward in manufacturing, design for manufacture and assembly, also known as DFMA, and industrialized construction, prefab in relation to mass timber high-rise, density, housing, sustainability, and carbon neutrality, where parametric design fits into this process, the definition of parametric manufacturing and mass customization, what it's like building an industry from scratch, building architecture on top of tech in relation to a tech-first company versus a project-first or architecture-first company, and why systematization must occur before automation. As always, I hope you'll not only find value in this episode for yourself, but that you'll help add value to the profession by sharing it with a friend. You can also really help me out here at the end of 2022 by leaving a 5-star rating and a review on Apple Podcasts, which helps others find it through the power of everybody's favorite thing, algorithms. Finally, I have to say thank you once again to Kai Zhu at Intelligent City for referring OD and for helping make this episode happen. So without further ado, I bring you OD Krieg. OD, welcome. It's great to see you.
Thanks for having me.
Yeah, I'm excited to have this conversation. The work that I've checked out on the Intelligent City website is fascinating, and it looks like it's been around for about a decade, maybe since one of the early projects was done. I don't know. I'm going to let you tell the story here, but this isn't just like a brand new thing. This is an innovative company that looks like it's been incubating for a while. So I'm excited to hear about that. And so I'm hoping that you could kind of kick us off by telling us how you've gotten to where you are today at Intelligent City, kind of a little bit of your origin story.
Yeah, for sure. That's correct. Intelligent City has been around for over a decade. The idea has probably been around, our two co-founders would tell you, for over 20 years. I joined in 2018 when the company sort of became a venture capital oriented startup. Before that, I worked for 6 or a little longer than 6 years in research in academia. My background is I'm from Germany. I studied in Germany, and happened to, during my architecture studies, happened to come across computational design and robotic fabrication. Got stuck with that topic for quite a long time, so much so that I did my PhD in it, and kind of took a very typical, if you know a little bit about the academia scene in architecture or architectural design research, I kind of really went into the trajectory of becoming an academic when I came across Oliver Lang and Cindy Wilson, the co-founders of Intelligent City, and we started talking about how some of these technologies that I was researching could be applied in the industry. And then I made that transition. And since then, I've been working with Intelligent City, starting basically with 4 or 5 people. And now we are over 30 in developing all the technologies that Intelligent City uses to deliver basically what we call housing as a product, as a complete start-to-end delivery process.
Yeah, that's fascinating. And you studied at the University of Stuttgart in Germany, and it sounds, I would love for you if you could give kind of an idea of what that program is like as far as robotics and fabrication and computational design, because I'm just interested in hearing kind of where academia's perspective is in different locations. It sounds fantastic.
Yeah, absolutely. I mean, it is very different nowadays than it was when I was a student that was around 2008, was when the Institute for Computational Design and Construction, or ICD in short, was founded by Professor Achim Menges, who is a well-known figure in the field. And so it was a bit of a celebrity coming to our university, and I was really just very lucky to just have been there when it happened.
Good timing.
I would say I was always interested a little bit in programming. I learned some PHP programming when I was 15, and dabbled a little bit in Cinema 4D and Maya early on. So I had some tendency towards being interested in programming and technologies and 3D modeling. And so when that institute was founded, Achim Menges came with basically the money to buy an industrial robot. And so he was the first in the faculty of architecture to have the ability to use some of those machines that we now all know so well, and experiment with that. And so I became a student assistant basically, and helped set up the lab and learn how to use the robot, and experiment mostly with milling processes. So we kind of naturally went towards wood, using wood design, timber construction, different techniques, trying out what the robot can do, what kind of shapes the robot can mill that you otherwise wouldn't be able to use. And so we did a couple of courses in timber joints, like parametric timber joints. It's almost old school now, but it was extremely interesting back then. And we built a repertoire of sort of processes, manufacturing processes, that we were able to then use in a context of building maybe a small installation or a structure, or a pavilion, basically. So back then, I was really just an architecture student that took courses at the institute. But later on, the ICD, together with the partnering institute, made their own master program. And so when you're a student now, it's called the ITech master program. When you're a student now, there is a very rigorous 2-year program where you go through learning about computational design theory. You learn programming, you learn programming robotics, you learn building your own little robots, with Arduinos and so on, kind of along the side of other, MIT or Harvard, where you have these courses where you learn to build things that build things in a way. And you learn that integration, I would say, between hardware and software, and what you need to develop from a hardware point of view in order to make some things that you can then design with. So a pretty versatile education in terms of rethinking manufacturing processes and integrating that with parametric design processes. And sometimes it's with wood, sometimes it's with other materials. The Institute is known very well for fiber structures, carbon fiber weaving or glass fiber weaving. There are a couple of projects that came out of that. And of course with wood, because it's such a friendly material. It's so easy to use, and it has so many interesting characteristics, bending, moisture, and things that oftentimes, the kind of the principle is that there's a characteristic that was previously suppressed in an industrialized manufacturing or construction method, and now we can actually use that and employ that. So it kind of rewires your brain. I came into it as an architecture student thinking I would be the next, fancy architect. And everything was sort of form motivated. And I learned that having a bit of a more scientific mind when you don't have necessarily a end goal in mind, you're more curious, you're trying to figure out things sort of bottom up instead of top down, then you could figure out some really interesting methods, different ways to build things in a smarter way, in a more performative way, save more material, have a more customizable or variable design, that can accommodate certain like more variable design intents, basically, right? That's what parametrics is to me, is the adaptability.
Yeah. Can you give an example of what, like something that actually reveals visually to me, like what a bottom up instead of a top down approach is? So it sounds like you're not being dictated by process that is already established. It sounds like you're developing material and code and all of these things to create a new process. Is that on track, or is it something different than that?
No, that's true. I think in most cases, the process is both a process how it should be in the real world, but also a sort of an exercise for your own sort of rewiring when you come from a design-driven field. And that is that sort of, yes, you have to think bottom up. And that means be curious about the piece of technology that you are working on, that you're interested in. And don't think in the beginning necessarily how it will look like in the end. Just think about what that piece of technology can do, right? What does the brick want? Think about the brick first before you think about the wall. And so I think a really good example is actually one of the projects that I worked on very early on, which was the finger-jointed plate structure pavilion. So we developed, and that's actually exactly how it happened. The final result is a very intricately designed 10-meter, 30-foot long pavilion that is made out of 750 plates, plywood plates that are all finger jointed together in various angles and configurations, and it looks really, really detailed. But that shape and that design and how they all came together wasn't the original idea. The original idea was, hey, we have a robot that has 6 axes, 6 degrees of freedom, and a turntable that's attached to it, so that's 7 axes. And we can mill finger joints using that robot into the edges of plywood plates. And we can mill any angle, and we can connect any material thicknesses together. So let's see what we can do with that. So we first developed that process of a robot basically milling around a polygon and adding all these finger joints in at different angles. And then we thought about, okay, so if we can connect any plate in any angle, what kind of structure do we want to build? What kind of structure makes sense to build? And then we actually went a step further and we looked into biomimetics, we looked into biology, we looked into biological examples of plate structures and found the sea urchin and the sand dollar, which are plate structures that are made out of separate skeleton pieces that are kind of stuck together with finger joints, actually. It's very interesting. and they have a certain logic, right? And that logic that we use that we translated that basically back into a structure, and decided, there are certain rules how these plates have to come together. And so then that led to what we call a building system or a material system, sort of the logic of how parts come together and form a larger structure. And that then was programmed into a parametric design workflow. And then we used that parametric tool basically as a design tool, and we explored from a design perspective what we could build. And because that tool was programmed to follow the rules of the building system and the manufacturing constraints, you would never be able to go outside of what is actually buildable, right? So everything you design would be immediately buildable. And so we explored what could be built, what could be designed, and we decided on a certain shape. It usually becomes a very organic bubble shape, because that's kind of lends itself very easily to those shapes. And we tried different variations, and that's how we ended up on with those kinds of pavilions that you can see.
I remember vividly the era of pavilions, right? There was like you're talking about the carbon fiber pavilions, the winding, and I've even seen it examples done with drones where they're carrying the lines and weaving them back and forth and going around an apparatus, and it dries over time, cures over time, and that was, I remember when at Autodesk University, like there were so many talks about pavilions and different construction methodologies and techniques that were either robotic or some autonomous kind of a system to build it. Really, that was an era for sure.
The era of the pavilion, and the pavilion itself as a typology for design research is definitely, it's still valid. And it was just the right size, right? The right size and the right use. It needed a structural engineer to sign off on it because it's a roof over your head. So it was serious enough, but it wasn't a full building. It didn't have much of a insulation layer or cladding or anything. So they would usually be temporary. After 3 or 6 months, we would demolish them afterwards. But that wasn't the use, right? The use was to test a manufacturing process and a computational design process, and to show what that together can accomplish. And usually they were extremely material efficient. They were super thin. They had a certain level of performance that we were able to test out on a larger scale.
Yeah, and also just that final step of constructability, right? Because there's always kind of this question when in school, like, is it buildable? Is it constructible? And to actually put that to the test and put real money into it, right? At some point it gets out of the computer or off paper or however you want to think of it, and it becomes a real thing. As a student, I bet that had to be really satisfying to see those things get built.
Absolutely, yeah. I think, and also very scary, right? You're making a schedule, a construction plan, and you're scheduling. You have to mill 40 plates per day on the robot, and you really make shifts in a way, and things go wrong, of course, right? That's always part of it. I think the success of that institute in particular, and many of my colleagues that worked on these projects, was because we were somehow able to navigate the risks, right? And we knew that let's not push it too far, but we'll push so that we can make something that's really exciting. And for every student involved, it was really always a great experience.
How far, I just have a sense, and I've heard from other people who, especially kind of in the mass timber arena, talking about Switzerland being really far ahead as far as direct to fabrication, the DFMA process and just all of the CNC milling. And can you give an idea of, and I'm talking maybe from the US point of view, and I'm not sure where Canada sits in this, but how far ahead, how far behind? Can you lay out kind of the spectrum of what you see? Because you said something earlier when you were talking about starting there in 2008 or 2012, you threw out a date and you said, like the back in the day, and like it seems like, but that was a decade ago, right? And so I know things have progressed since then, and I have a sense that we are decades behind in the U.S. of where things are when it comes to DFMA in those European countries.
Not necessarily. I think when you look at that kind of research that we were doing at the ICD in Stuttgart, yes, there are a couple of or a handful of other universities, or maybe even more nowadays, that are doing the same thing in Europe, in Switzerland and in the UK and Spain. There are also some in the US and in Canada. I would say, especially Michigan comes to mind, and there's also Calgary. They have a robot lab. There are definitely many universities these days that have in the architecture department. That's really important, right? They have robots and other equipment in the architecture department that they are experimenting with. But you're mentioning an interesting point, which is DFMA and sort of that advanced thinking that relates more industrialized construction and what kind of equipment is out there and what can be used to design buildings, or what impacts the design of buildings.
Right.
And I would argue that even though those research institutes that are out there are really advanced, they are sometimes almost too advanced to make a significant impact on the industry.
Yeah.
I think the students coming out of that, they have a really extremely versatile set of skills, and they could go, they can go to Adidas or Nike and help them develop their parametric weaving methods and stuff like that. And they can go into bigger architecture firms and help them build tool sets. But I think there is definitely a bit of a disconnect to how these technologies can actually be applied in the industry, and what kind of impact they can ultimately have in an environment, where industrialized construction or industrialization is quite far away still.
Yeah. I mean, you made a comment before we hit record about the two bubbles of academia and industry, and how those bubbles don't talk to each other, right? And so, I mean, to illustrate that point, what you just said makes sense, right? It's like you get to a point at a really avant-garde institution that is, an academic that is pushing the limits of what robotics and computational design and real world materials and construction are capable of, and then you graduate and go where? Like, I know that there's some places, I mean, Intelligent City is probably an example, right? But there aren't that many, and when you get into when you actually graduate and become an emerging professional into a profession that's done things the way they've always done things, right? And there isn't a huge incentive to invest in completely new ways of working, because the machine, the business machine, already works the way that it works, and it's known, right? It's hard to evolve that to a level that would match what academia can produce. So maybe talk a little bit about kind of even your journey there. So you found a company that you found the need for that kind of thinking to be applied, I assume. I want you to tell that story a little bit deeper, but versus kind of the total landscape that's out there. I mean, it's a pretty small piece of it, I assume.
Yeah. The problem, actually, it's a curse and a blessing that academia, or especially architectural design research, is quite far removed from the industry. And I'm saying this because, yes, you graduate from Princeton, Michigan, Stuttgart, Zurich, AA London, and then what, right? Like, where do you go? You go to an architecture firm where you have 5 people working on programming some grasshopper tools that no one wants to use in your company. Or you go to some kind of design company that does some really advanced stuff. But where do you get to use robots to actually build buildings? Right. There are not that many out there. But so it's a curse, because I also got to admit, when I was fully involved in academia, I also kind of sort of looked down on industry, because they're not using the tools that we're developing, right? They're not doing that stuff. And in some ways, it's the same way as well from industry, right? No one from big architecture firms knew about those pavilions, right? Because
Right.
just building pavilions, right? Well, that has no effect on the larger industry, right?
Why are you training people to run robots? We don't use robots, right?
Exactly. Yeah.
Yeah. Big
Um,
disconnect.
yeah, it's a big disconnect, but that's what I'm saying. It's also a blessing because it allowed us to dive really deep and it allowed us to own a robot, right? And like, I had a key, I could go and use the robot whenever I wanted to. And that level of integration doesn't exist anywhere else. And that level of integration, and also the fact that the robot itself is a new tool to all involved in the industry, right? It's a new tool to construction companies, to engineers, and to architects. And because it's so new and sort of untainted, um, everyone approaches it with a sort of a clean slate, like open mind, like what can it do? And so it really allowed us to approach it sort of in a very naive way, and then also to really integrate it into a design process, into a level that I think most people still haven't understood. And I think that was a very important lesson, and sort of I kind of immersed myself in that environment for a very long time. And so when I came out, and then when I talked to Oliver Lang and Cindy Wilson, the co-founders of Intelligent City, they didn't talk necessarily about, oh, we need robots to make our buildings. They talked about, we want to find a scalable technology to deliver mass timber urban housing in a consistent yet customizable way, right? And when I heard that, I thought, well, look at that. That means you need a parametric design workflow. You need parametric tools to control what you can design and to control that customizability. And you need some kind of manufacturing flexibility to produce all these various or varied building components, right? And so that's suddenly when it also to myself kind of made sense that what I learned actually can be applied in the industry. And so I think it was good that I was detached, that we were detached for such a long time from sort of the typical problems and the fragmentation that you see in the industry, because it wouldn't have allowed, it wouldn't have offered such an environment to come up with these ideas.
Well, would you have to say the same thing for the co-founders of Intelligent City, where they also didn't have kind of a tie to delivering projects in the way that everybody delivers projects either? They recognized that they needed a different way to do that, and somehow your paths crossed, right, in order to facilitate and make this eventually happen. But I would say, equal kudos to them for having an open mind about, like, I don't know what they didn't know, but they knew that the way that it has always been done was not the way that they wanted to do it, even if they didn't know what the way they wanted to do it was yet. I think that's really interesting to think of them and you coming together at this particular point in time.
Yes. Yeah, absolutely. I mean, it was extreme luck, and the time was ripe as well. I think parametric design and robotic manufacturing had matured to a degree that it could actually be applied in seriousness to a larger part of the industry, and not just for I want to call it fringe projects. Of course, there are fantastic projects out there that have been parametrically designed, and I love them. But they were always these very special one-off lighthouse projects. And I think Daniel Davis wrote about it, right? Like the actually interesting part is the boring part, right? It's like the big chunk in the middle where all the housing and all the the fat middle, where all the housing and the office types are happening, right? And you're totally right. They knew a lot, actually. They were both architects, and they worked in. They had a little architecture firm, and they experimented with housing typologies, especially for Oliver Lang is German as well, as it happens, and and they met in Europe, and they traveled the world a little bit and sort of saw quite a few different building typologies. And so they came to Canada basically with a bit of an ambition to change a little bit this like big difference between single family housing and skyrise towers, right? And so the sort of the what's called the missing middle now. They experimented with that already in the early 2000s, and with every building that they built, they kind of realized, okay, the construction of it was terrible. It was very difficult to even have new design ideas because the construction companies were so used to the typical way things are built. And so already in 2009 or so, they actually got, that's kind of when Intelligent City was founded sort of officially, because then they actually got a shop and they built stick frame modules themselves to build one of their buildings. And then they did that a few more times. And then they realized, okay, we have to change also the way these things are built, because just manual assembly in a shop isn't going to cut it. But the idea basically came from an understanding of what good design, good livability is, what urban housing should deliver, the idea of urban housing. And how can we, now that we have found good design ideas, how can we replicate that and bring it to a larger scale and deliver it in Vancouver and Toronto and in New York and California? Like how can we scale that up? And so then the idea of, okay, we need some kind of system, right, that can accommodate that. That's when sort of the technology came in. So it's design motivated, and I also think personally that's extremely important, because I don't think that prefab companies will save us. I think it is architects. It is those that understand design and functionality as much as the technology that is behind it.
It's interesting, like the thing that really stood out to me when you were going through all that, and then where you just ended talking about design. The older I get, the more I recognize that the experience of experiencing buildings, good and bad, and everywhere in between, how important that is to being a successful architect. Right? It's not like you don't just come out of school and because you're an idea generating machine, come up with good architecture necessarily. And just because you've been practicing for a long time doing maybe a certain project typology doesn't mean those are great buildings, right? It really is kind of this perfect scenario of and or imperfect, I don't know, but it's through that experience of curiosity, paying attention, really being observant. What makes it good? Why does it feel good? How does it make me feel good? And it really trying to kind of quantify and qualify those statements and those feelings over time to where you can get to the point where you actually can say, this is the value of design and this is the value of architecture, because just how it looks is not where that ends, right? I think a lot of people just look at that and they say, okay, well, it looks like a great project, therefore it is a great project. But I think this is what, if you go all the way back to like Alexander and pattern language, and it's like, how do things feel? Why do they work the way? Why, when nobody was paying attention and it worked out to feel like this, why did that feel good? Why did it matter? It's such an interesting intrinsic part of architecture. So it's really interesting that you say like the founders and starting this company, Intelligent City, understood the value of design, and that design was going to make a difference, even though they were hitting other walls along the way of constructability and the way parts went together and the way those details were probably flashed and like all of those kinds of things that were just kind of really practical things along the way, understanding that this is a really complicated puzzle, right? There's a lot of pieces to it, and some of it is not easily quantified either. So it's just very interesting to kind of think through the larger kind of architectural aspects of this conversation as well.
I totally agree. And I think it's, without it, I think we would not be able to change our industry. And, I also don't want to put architects on a pedestal. I think what you're saying is extremely important, right? It's the flashing. It's the details of how things come together. And there are so many layers that have to come together. And we need a lot of expertise and experience in that as well, right? We are extremely dependent on our building envelope engineers and on manufacturing experience as well. That there's so many things that can go wrong. Yeah, exactly. Right. But of course, at the end of the day, a car or a laptop or a phone is successful not because of the way it's made. It's successful because the way it looks and feels and functions, right? It's designed, and I think that's really important, and that's why we are calling ourselves a product company, because the idea that is that if a building becomes a product like any other product that we are buying, and the decision process you go through when you buy that product, what's its value, what's its performance, and so on. But one thing that's most important is that it is already pre-engineered. It is already thought through when you buy it, right? You're not buying a phone and then people are starting to design it. So it has to be pre-engineered. It has to be figured out up front so that you can actually go and buy it as a product. But that means, of course, you have to put in an incredible amount of work to figure it all out up front.
Right.
So
right.
if you do that once for one building and then you sell the building, that doesn't really make sense, right? So it only makes sense if you can sell multiple buildings. But then now you're stuck with selling the exact same building over and over again. And that doesn't make sense either. You can't rubber stamp these buildings across the continent. So you need that design flexibility, right? You need customization, mass customization in a way. So you need the technology ultimately to arrive at a scalable business model. And that's really the truth at the end of the day is you need a business model that makes sense. And in construction, that's pretty difficult because the cycles are so long and so slow, and innovation is so difficult. So you need to find a way that every hour you spend in R&D can be multiplied afterwards when you apply it to different buildings, and the buildings that look different and that are different typologically and topologically. But what you developed is versatile and customizable enough that it can be applied to all of these buildings. So that's what we call a parametric platform, a parametric building platform or parametric technology platform. Is it's platform-based design, as you might know it from other industries, but it is all thought in a parametric way.
This is a fascinating idea. As you're talking through that, because I've been a part of many architectural projects, but nothing like what you're talking about, where it's a product. It's always a distinct solution for a distinct client for a distinct site, and I might not have even worked on the same type of project 2 times in a row, right? So not product-based at all. And so the thing that fascinates me about what you're talking about, this flexibility of the tools to provide different outcomes, but still make the process make sense as a business model, is interesting because you have to do so much preloaded thinking in this. And I'm just wondering, before we get into what the platform is, what it does, kind of what Intelligent City means, what the business is all about, can you just talk about kind of the depth or the to what degree do you have to figure out the possible in the tool set that you're creating up front for, and I'm sure it evolves over time still, but it seems to me like you have to go quite a bit farther earlier in creating a platform like this, a tool set like this.
Yeah, that's a very good question, because it's ongoing, right? It's as we are working on projects, we are discovering sort of new variations that we might not have thought about before. But and that's fine. That's the idea is you're developing a technology that will have a certain version. And once you finish that version and then you use it, you apply it into different projects, right? As you do that, you discover that you can change things and you can update things. And so you start developing the next version while you're applying the previous version. So it's a bit of a sort of an agile development process, as you might know it in software development, where you have multiple teams working on the same product from different perspectives. So you think about the product, in this case, as the whole building, or you can divide it up into different building components like the envelope, the superstructure, mechanical, electrical, plumbing systems, and so on. And so they have certain design requirements. that come sort of from our product definition and from the business the definition. And so multiple groups are working on that definition from an engineering point of view, detailing, from a manufacturing point of view, and from a software development point of view, about sort of what are the rules behind those particular details and how can we program them into our parametric design tools. And that's basically when things become really interesting, because everyone working on these details and the building systems and how things come together has to work on them from a perspective of not what is the single solution, but from the perspective of what is the minimum and what is the maximum solution and what is the range in between. So every building part is not defined by a single set of dimensions or characteristics, but by a range of characteristics. And that, if you add it all up, right, every building part has a certain range. Every screw, every piece of CLT, mass timber or plywood has a certain range of what's its minimum, what's its maximum size. Put it all together, that's your design space. That's your solution space. That's in which you can design. So in some ways, that sort of computational design thinking or parametric thinking is sort of ingrained. But of course, it's extremely difficult to keep that awareness up, because the more complicated a problem is, the more inclined you are to find a single solution, because otherwise you might not find a solution at all, right? So you end up, of course, with many details that are sort of singular, and they can be applied to a wide range of buildings, but they might still be its own single solution. And then you have areas where you have more flexibility and you have a range of solutions. And so that it's a combination a little bit. But that thinking is very important. And then the thinking of versioning, as I said, that you kind of let's figure out, the following set of building components, because we know we have, a handful of projects that are a certain typology at the moment, and we'll figure it out for those. And then we'll figure out an updated version later on as we go along. So there's then, of course, also the constant feedback between the projects and the platform.
I want to ask a real, maybe nerdy question. How do you do that with tools? Do you have like GitHub? I mean, is it forking and versioning, and is it like that? Like, it just seems like this never ending process. The tools are never done, but there's just kind of like the latest version kind of thing happening. I'm sure at some point a project is locked into a certain tool set, but it just seems like as a alternative to traditional practice, right? Where it's like, we use Revit and we're going to use the version 2022 of Revit for this project or whatever. Like, this seems a lot more like there's a lot of overhead that you have to manage when it comes to software and versioning, and especially as it translates into fabrication and robotics and all those things.
Yeah. Documentation is key. I think you had a podcast about that as well at some point, how important it is to not lose information along the way, right? To document it in a proper way. So yeah, we're using GitHub in the software team. We are using Confluence and Jira for all teams. So we are collecting and documenting our R&D process, and we are using project management tools, both in a waterfall way and in an agile way, to kind of keep track of all the things that are currently happening, and to keep track of also sort of when we want to get to a certain version. Building systems, manufacturing, software, all these teams have their own versions that they're working on, and sort of together that forms then a sort of larger version of our platform.
And there's all these teams. Are they actually collaborating throughout the entire process? It seems like they would have to, whereas instead of like a very particular like handoff process, doesn't seem like that would work very well in this kind of a scenario when you have all of this going on at the same time.
Yeah. No, exactly. You're right. I mean, we are still at a size, I would say, where many people have multiple roles. And so there is a lot of natural overlap. But as we grow, we have to sort of systemize and institutionalize this level of integration a little bit more. So yeah, we have mechanical engineers, roboticists, computational designers, software engineers, architects, structural engineers. But I mean, we all understand this. Also, it's a great company to work in. I want to say we all understand what we're working on. We all understand that we need to integrate and we need to talk to people from other teams to understand what their requirements are and how we can combine that. So I'm also going to say it's a challenging process, of course, right? No one's done this in that way. And it's easy to shut yourself out of that process. It's easy to sort of focus on your deliverables and just do that and then forget about manufacturing, for a couple of weeks. I think naturally the development process would fragment, which is quite an interesting experiment, actually. So we kind of have to actively work against that all the time. But I think so far, I can only say that I think we have been doing a great job because I think it's a very challenging process to do that.
Let's take a quick break to share more about our sponsors. You've heard about Avail here on the Troxel podcast, and I'm excited to tell you they have a new message for you, my friends. Avail is designed by designers for design professionals, so it's no wonder Avail focuses on visuals in its platform. While Avail has always provided high-resolution previews, there are some new visual enhancements you should know about. These are channel cards and key cards. They're visual gateways to your content, and they're both customizable. Channel cards have been available since Avail Desktop 4.0. Think of them like album covers for each content channel you create. Channel cards are designed to make navigating your firm's assets quick and easy. And with channel cards, the look and feel of Avail conforms with your firm's standards. Next up is key cards, and these are the latest addition to Avail and are available since version 4.3. What are they? Key cards visually group content within a channel, and they derive data from your tags to make finding content easier. So they're created from the work you've already done. By adding custom graphics to your key cards, navigating content within a channel improves immediately. Key cards also drive the breadcrumb trail in the latest Avail Desktop 4.3 release. Navigate through your channels using breadcrumbs. And a new breadcrumb control is displayed on a channel when navigating with key cards. Breadcrumb items allow the user to navigate to the previous state easily. To see all of these new visual enhancements in action, head over to getavail.com to learn more. That's getavail, GETAVAIL.com to learn more. And now let's get back to our conversation. The alignment of incentive is what I think is different maybe about a company like Intelligent City and a lot of other architectural practices where different people have different incentives in the same office in a traditional architectural setting. It's like business development people are incentivized by signing contracts. Project managers are about schedule and hours worked on a project. Designers are maybe incentivized by awards, for example. And a lot of times these things are in competition with each other. And it creates silos and it creates kind of, not everybody going in the same direction. It doesn't sound like that at all at Intelligent City. It sounds like like you said, we all understand kind of the outcome that we're after and we all have to achieve it together. It just seems like a very different structure for the way that teams work and work together.
Yeah, I think it is. And we are moving away from the project thinking, right? I mean, we execute on projects, right? So you have project teams, right? You have an project architect, intern architects, and a project manager, and so on. So there is, and then of course you have the industry, which is like a tsunami wave that washes over you, and then suddenly by the time you come up for air, you're back in the project.
Coming. Yeah,
right. Yeah, exactly. You're like it forces you to go back to a project thinking.
Yeah.
But the way what we're saying is because we are not a project company, we are a product company, and so the product results in projects, right? Each project is an outcome of the product, iteration of the product. It's using a certain version of the product. And every time we engage in a project, we take the knowledge of the product and apply it, and then we learn from it and we put it back into the product, right? So that is fundamentally a very different kind of thinking.
It
And I
almost
think that
seems to me like a process company.
Mhm.
Like it's like you're constantly evolving and iterating on the process, and products are the outcome of that. I totally understand what you're saying, but it just really sounds like you're all focused so much on the process of delivering the product, even more so maybe than the product itself, even though that's where the real value lies.
Yeah, no, absolutely. And everyone understands that, manufacturing, software, they all understand that we need to deliver on the product so that we can convince real estate developers to use it. Right. And that's the success. Like
the case
you can
study, right?
Yeah.
Yeah, they have
you
to
can
see
be
it.
ready with you can have manufacturing, all waiting, but
right.
If there's no project to deliver, then that doesn't make sense. So I think that's a good observation.
And so from your standpoint, I do want to talk about Intelligent City and like the actual product, but one more thing here. I promise. It just seems like this focus on a certain project type, or a product type, I should say, really enables what you're talking about to happen. Whereas a lot firms might be participating in different market segments, like they're doing civic work and healthcare work and education work, and everybody's doing it differently. The AHJs all need a different set of things to be, all the hoops to be jumped through at certain times, and there's like no way to drive consistency in a practice that does different project types. So is that really kind of what is gluing all this together? Is just that focus on the one product type?
Yeah, absolutely.
Okay.
And that's a very interesting question, because I think architecture or the AEC industry has just absolutely no comparison to what a systemized industry could look like, right? If you're an architecture firm, oftentimes you do anything, right? Any kind of project, it doesn't matter. All the tools that we have can do anything, right? All the BIM tools and everything, and all the software and all these processes are made to accommodate any typology of building. And it's like, it's so hard to compare, right? I mean, I really like trying to compare our industry to other industries, right? Like, let's compare ourselves with the car industry. It doesn't always work. Like, what is a good example? I always think that it's basically like everyone is just a custom motorbike company, and you can just go anywhere and get a custom motorbike. And now suddenly there's a company like Ducati, and they come in and they say, hey, we have these 12 different motorbikes you can choose from, and they are, really well designed and built, and they're a lot cheaper. And then everyone comes and it's like, oh, but I would like to change the exhaust pipe into this location, right? Can I change your wheelbase? And then you have to say, no, we are focused only on these certain products. And it's such a wild idea from the perspective of the AEC industry to do that. But it's extremely important to stick to your product definition. Otherwise, you get distracted with all sorts of ideas and changes. And it's also always the death of parametric design is not understanding what it can actually deliver, and always either underestimating what it can deliver or overestimating what it can deliver. When you think, oh, if it's parametric, can we not design anything? Right. And you also have to say, no, there's only a very specific solution space that you can deliver. And if you leave that solution space, you slow yourself down, you grind to a halt, because now you're back in the manual process, right?
Yeah, interesting. All right, well, it's time to get on to Intelligent City, what the product is. I'm really interested in even why. I mean, I know you guys are based in Vancouver, correct? And so why Canada? I mean, you talked about coming from Germany, and I'm just wondering if there's something special going on there. I know, like Pacific Northwest, there's a huge emphasis on mass timber for sure. So maybe that's a part of it. But just give us kind of a rundown now of what the product is, why it's that product. I mean, you alluded to it in kind of the formation story of Intelligent City, but what is the problem, and why did you guys choose to bite that problem off and make that your problem that you're solving for?
Yeah, I think it's a combination of things. You're right that the Pacific Northwest is very receptive to our idea of housing density, densifying our cities, building more instead of the missing middle. And it is very receptive to ideas of sustainability, finding ways to build in a carbon neutral manner, both operationally and embodied. It is receptive to ideas of housing typologies, I would say. It's a mild enough climate to look at some variations. For example, Intelligent City really likes the idea of courtyard buildings because they allow you to have double-sided apartments, and so you can really make very efficient apartments that have cross ventilation and double-sided exposure. So they are much more livable as well. And so Vancouver specifically, I think, is very much incentivizing building prefab, building with mass timber, building sustainably, building high performance buildings that are passive house certified or close to that. So it makes a lot of sense. And of course, the whole idea of mass timber and prefab also makes a lot of sense in that context because Canada has a lot of forests and Canada wants to use its forests in a sustainable manner. So it wants to designate, certain areas for sustainable horticulture that can really produce value-add products. So not just exporting the tree trunks, but actually making use of them. Mm-hmm. So I think it's very logical that it started in Vancouver. But the markets and the demand for housing are also a lot bigger in Ontario and on the East Coast in general. Mm. So I think maybe Vancouver makes sense to start that company, but then there is such a big need for housing on the East Coast as well that it also makes sense that it's being applied there as well. And I think that the last point to your question is also why did I come from Germany to work here in the Pacific Northwest? And I think. Honestly, in the beginning, I wasn't sure about that. But now after I've worked in this field for almost 5 years and also coming back every now and then to Europe and seeing prefab companies in Switzerland, Austria, and in Europe and how sophisticated they are and how many there are. I think the North American market is, especially when it comes to mass timber and prefab, is probably 10, 15 years behind that of the European market. And at the same time, it's not as dense as the European market. So I think the potential for disruption and innovation is just a lot bigger. And also the ability to do it and not to get immediately crushed by, a dozen other companies that are competing with you.
That's an interesting point. I hadn't thought of it that way, but it isn't because we're lagging behind. There's still time to make a mark here. That's an interesting way to look at it. Yeah.
Yeah, so that
go ahead, continue.
So that's a very sort of a market that is ripe for innovation, and I think that the mid to high rise market is also, particularly in North America, very attractive. I think Europe is usually a little bit lower, so you're more on the low rise typology versus above 7 stories, or above 6 stories starting at 7, you're in the high-rise category. Now you cannot build with stick frame, right? And so you need a different material, and so mass timber also makes a lot of sense there.
Interesting. All right, a lot of pieces are fitting together there. I think that makes sense. And there's even been code changes that have recently passed, I think even in California, that have allowed mass timber to be used above, up to, was it 14 stories or something like that? 12. Okay. Yeah. So the code changes have also started enabling these project types to happen in more regions than less. So that's pretty interesting too. Okay. So as far as the kinds of projects, could you define kind of where parametricism, the parametric part of your platform fits into this design process? Because like you said, you can't just plop down the same thing in Vancouver that you want to do in Ontario, that you want to do in California. That right, it's every site's different, environmental, microclimates, climate zones, weather, all these things are different. And so it's not going to be the same thing everywhere. So how does your parametric platform, like where do parametric play a big role in driving? Is it upfront early in the design process, or is it throughout?
Yeah, the short answer is it's throughout. And I think that's also a little bit of the secret, I would almost say. And I'm saying this because I feel that the most important point that no one really understands is what parametric manufacturing actually means. Because I think in any other industry, when you talk about mass customization, especially in the car industry, that sort of coined the term, I would say hijacked it. When you talk about mass customization, what they actually mean is, you pick a color, you pick different seats, you pick different tires, but you can't change the shape of your car. You can't make it longer or wider, right? Because my particular parking spot is a little bit thinner, so maybe I need a thinner car. Well, but that's okay, right? Because we agreed in general that that's the amount of variation that is okay, and we don't need more variation than that. But in construction, that's not enough. We need a higher level of customization. And so when you manufacture a building, when you manufacture building components, I think it's not enough that you can just select between like a dozen different types of building components or variations of building components. To a certain degree, for some building parts, it makes sense. Like windows, maybe you have to handle your supply chain, so you order 100 windows type A, 100 windows type B, and so on. But when it comes to the overall assembly and the building shape and the grid of the building, the structure of the building, that's really dependent on the building site and, like you say, the jurisdiction and the climate and the client, of course, right? So the adaptability comes sort of, or the parametrics of it comes into play when you put it all together and you force it sort of into a shape. And then it doesn't matter if the grid spacing is 12'3" or 12'6" or 13 feet or just in general all over the place, right? Because maybe there are some apartments that need a larger living room and some that need a smaller one. That should be all fine, and there shouldn't be a step in between certain grid spacing or certain sizes of envelope panels, for example, like facade panels, right? So the parametrics really sort of, again, it's this thinking that goes from design to manufacturing. And why I'm emphasizing manufacturing is because I think that's an extremely important point. You cannot design something parametrically if you cannot manufacture it parametrically. You cannot suddenly have to make 150 different shop drawings for your building components by hand, right? This has to be automated. You cannot suddenly make 150 sets of machine instructions for your robots or CNC machines by hand. It has to be automated. It has to come naturally from the design process. So that is the sort of end-to-end thinking. And so you have to integrate how your design gets manufactured. You have to integrate that thinking, that every building part comes with a set of instructions, a set of characteristics or metadata, or however you want to call it. And that translates into machine code and shop drawings and all of that. But how that is generated, how that building part comes to life is the other part. It's sort of the front end of the design tool, right? It's how do you actually design a building with that system. So it's also really important that we develop a parametric design tool with which you can design our buildings in a very easy way, right? So then you raise questions of user interactivity or user experience, of course, as well, and how much is automated, how much is manually defined, so that you have sort of that maximum amount of speed and customization at the same time. And then you push a button, and then it goes all the way through. It generates all the components. It generates all the manufacturing data. And so, in essence, if a if a client came to us in the morning and we designed a building with them, we could start manufacturing in the afternoon if it was all, all the materials were there and so on.
Wow. And so do you guys control the manufacturing as well? Are you actually doing the production and then are you doing the construction, or do you work with contractors? Kind of explain the rest of it. Like, how does it actually become a real building?
Yeah. So we manufacture the superstructure, basically the floor cassettes and columns and all of that makes the superstructure of the building. And we manufacture the facade panels or envelope panels. So basically the structure and the shell, because those are the mass timber components. And there isn't really a mass timber prefab company that you could outsource this to.
Okay.
There might be, in the future, maybe there will be more prefab companies that accommodate such a systemized thinking, and they could manufacture it for you, so you could outsource it. But we also see this; it's a very connected technology, right? The way we manufacture it, the way we use robotics, where we use it, and where it's more of a manual or a traditional process. It's really sort of very ingrained in our building systems. So we handle those components. And then we collaborate with an on-site general contractor who then takes care of foundations, underground, and also the interiors and some of the MEP systems as well.
So the interiors, the systems are put in once the superstructure is erected. It's not like these are prefabricated modules in a factory somewhere where a lot of that's being done and then just delivered to the site practically complete. It's still kind of a traditional building process, except that all these parts have been pre-cut, numbered, and they're going to go together in a very specific way once they reach the site.
Correct. So we're not doing volumetric modular. We are doing panelized construction.
Okay.
And, there are advantages and disadvantages. I think you recently had a podcast about that as well.
Mm-hmm.
It's volumetric modular has advantages in terms of the level of finishes that you can produce, right? But you are also slowed down in the process, and you need very, very big factories to make these modules. And then everything is also sort of a module thinking, like a box thinking. Mm-hmm. Whereas when you go, what we are doing with floor cassettes or floor panels, it's really just a big slab at the end of the day, and you have a lot more freedom for the interiors. Sure. Nevertheless, however, the combination of how your structure looks like and what kind of apartments go in and where all the services run is a very connected problem. And so we design and engineer all of that, but we don't prefab it ourselves. We then hand it off to other companies.
And you're also doing the interior design as well as part of that, right? You're not just designing the structure, you're doing the entire design.
Yeah, we're doing all the architectural services and all the design services. And we basically have a team of consultants that we like to work with. Some of that stuff we are doing in-house as well, some of the engineering. But with the current size of the company, we are really, it's a bit of a lesson as well, I think, from other companies that failed, is that you have to have local collaboration. You can't have your whole engineering team just in Vancouver and then work in a different jurisdiction. In Toronto or in Atlanta, you need to form local supply chains and local consultant groups that can work with you.
That know the region as well, I would assume.
Yeah, exactly.
Yeah. So, okay. So can you just define what the product itself is? Though you've said some kind of general categorical things, but can you get more specific? Is like what are the constraints that you're working within with these kinds of projects?
So basically, we deliver mixed-use urban housing in the mid to high-rise range. So that's anywhere between 4 and 18 stories. Ideally, I think the probably most important market is around 8 to 12 stories. And I'm saying mixed-use because our building systems can accommodate office and commercial spaces as well. So it can make a switch between commercial and residential. And oftentimes buildings in urban densification scenarios have that. They have a base, right, a commercial base. So from the ground slab up, everything can be made with our mass timber components. And then we basically have a certain the skeleton of the building and the envelope of the building is made from mass timber, and there are certain ranges of grid spacing that we can accommodate, but then you can basically put many different types of cladding, many different types of facade articulation, many different types of balcony systems, and you can put in many different types of apartments. Right? They are figured out, pre-designed, pre-engineered. So we know what kind of apartments fit with what grid, and we know what kind of balcony systems can be attached to it. So you basically ultimately have a configurator that doesn't really exist in full yet, but you kind of go from building shape to facade articulation, balconies, apartment types, interior choices like kitchens and bathrooms. You kind of go down the list in your configurator, and then you can adjust that in size depending on what fits onto your site.
And how long did it take Intelligent City to get from, I guess, when they talked to you to this point? Is this 5 years, or is it this didn't all happen at once, right? You didn't start with all of these tools at your fingertips. So what does that development cycle kind of look like for somebody who would be interested in learning like the speed of development of just the technology to do this?
Yeah, it's hard to say because, of course, during those 5 years, we also learned a lot of things and made some decisions and changed things as well. And it's a lot about setting up the infrastructure as well. The software architecture, for example, on the software side, it's really important to understand, like to set up how a building is designed, like what is the software structure of a building. And then once you have that, it's pretty easy to add a couple more apartments or a different kitchen type, right? Sort of the parametric floor plan idea is pretty easy to adjust afterwards. So I think it took us probably 3 or 4 years to figure that out. And on the manufacturing side, in a similar way, it took us probably 2-3 years to figure out what in a manufacturing process we want to automate first, and which parts we want to keep sort of in a more traditional assembly line, manual assembly line, and we want to automate later. So I think it's also because of that combination that you have to think about building systems, manufacturing, and software all at the same time. You kind of need to make sure everything is being taken care of as you sort of progress in your understanding of what the product really is. And then on top of that, you have realizations what the product market fit is, right? You have to understand what developers are looking for, what kind of buildings make the most sense, what kind of apartments make the most sense, and then that influences also the development process of the technology.
I'm just shaking my head because it's pretty incredible to really think about the speed at which this has happened, because like that's a normal architectural project is 3 to 4 years, one project, right? And for you to develop this technology during a time span similar to a project in architecture that allows you to deliver a multitude of projects, right, is totally fascinating to me. And it kind of makes me think about the idea of the way that the company is set up as a technology first company. Not that it's not like you had all this technology sitting around and then you figured out how to apply it to solve this problem. Obviously, these two things went together, and it's this back and forth, one informing the other the entire way through. But the company is built on technology, whereas traditional practices are built on traditional practices and the traditional way, the traditional business model, waiting for a client to knock on the door, going through the programmatic process, going through entitlements, going all the way through to delivery, and really just applying generic technology to that process to hopefully solve the problems while acquiring technical debt along the way, right? Because when using generic technology, like every firm out there is getting into deeper and deeper technical debt every time. And I can only assume that that's like, is not allowed in your company. Like, I'm sure it happens sometimes, but for you're avoiding that at all costs, right? Because it matters so much to the process to never get into technical debt along the way. Like, you can't fake something that's going to hurt you
Mm-hmm.
later because
Mm-hmm.
your product depends on it and because your process depends on it. Where in a traditional firm, it's like you said it, the tsunami is here, the tsunami will go away, and we'll have a whole new tsunami to deal with later. And who cares if we don't remember to fix that one little thing for the next project? We'll just fix it again then, because that's just how projects are forecast, and that's how we apply labor to them. And there's so much inefficiency built into those that I think it's just assumed that that technical debt's going to occur and that we're okay with it. I can only imagine like that's absolutely not even on the table where you work.
Well, I think you just gave me the idea that we should put a really big banner into our office that says no technical debt.
How many days since the last technical?
Yeah, exactly.
the last technical debt incident. Well, yeah,
No,
I mean do you have anything kind of just to kind of talk about the point about being built on as a technology first company versus, and I'm the reason I bring this up is not to like shame anybody for saying like this is the way it should be versus, but like, let's be honest, it's going to be very difficult for a company that's been around for decades, if not longer, to pivot to a different model like this, because it is so hard to just totally change gears, right? And move away from a proven business model, proven in the way that it's always been, and maybe not the way it's going to be in the future, but just like it kind of works now, versus this thing that is entirely different.
Yeah, it all goes back to systemization, right? It's this idea, and I think you had a conversation with Paul Winter where you talked about that you kind of you rush from project to project, right? And every time the project ends, you just sort of clean slate. Let's not think about it.
Sweep it under the rug, right?
Yeah, never open these models again. And then you start from scratch and you make the same mistakes again. I would argue that any architecture firm, even in a traditional model of delivering architecture, could do so much better if they systemized their own processes and if they figured out what is the underlying logic, the underlying rules or the rule sets of the way we design buildings, the particular buildings that we like, and the processes that go with it, and let's try to write it down, systemize it, all agree on the same process, which is always the first step. Like before automation comes systemization, right? You first understand your process, and then you can automate it. So that would help anyone, but for some reason, our whole industry is built around that extremely custom, extremely fragmented process, and that also makes it very difficult to innovate from within, right? It makes it very difficult for any company to change their processes because they would have to change their organizational structure and thinking, and they would have to change the inter-organizational structure and thinking as well.
Right.
I read a whole bunch about that because I was so interested in how fragmented our industry is and how difficult it is to innovate in a fragmented industry because you're so dependent on the connections to other entities over which you don't have control, right? So that's where systemic innovation comes in, sort of when the whole system changes. And I think we found a good way to innovate, to just have enough vertical integration so that we can innovate, in a large sense. But then we still have these interfaces to the outside world that we have to adhere to. And that's sort of a constant battle, of course, right? So
Sure.
I wouldn't say we are not accumulating technical debt, but I think we all understand that we'll do this like the exact same thing again in a couple of months, right? So let's make sure we understand it exactly. But at the same time, every architecture project is different ultimately, right? Every jurisdiction has different requirements.
Yeah.
Sometimes
you have to have some budget for technical debt.
Yes,
because it is not all the same all the time. It is not like an automobile, right, where you are going to build exactly the same thing every time.
Yeah. Or think about it as a plane manufacturer like Airbus or Boeing, right? Mm-hmm. They make really big objects and they're very expensive, right? Mm-hmm. And then they sell it to a provider who then customizes it to their own needs and then sells it to a user. I like that comparison a lot more, but still, all the planes are the same, right? It's not like that. It's like you're building a plane in a different environment every time. So there is a lot of customization that is oftentimes outside of what we can automate at this point. And the typical project workflow of SD, DD, CA, and so on, it's still happening. But I think we are all sort of driven by the fact that we know next time it'll be more automated, it will be easier, it will be more streamlined.
And again, getting back to that focus of project type really helps enable that to happen, right? Because if the next project was going to be a different typology, then you probably would sweep it under the rug and just move on, right? Because you know it likely applies to the next one, you're going to bring it back up, you're going to document it, you're going to figure out how you're going to solve that the next time, or at least do better. I do see like that. There's the ability to focus like that is a really big deal in this kind of business for sure. And
that focus is a focus on the market segment. So I would define it more like what's the market that you work in, what kind of variation is required within that market. And so I think the reason why we decided to go with the mid to high rise urban housing is not only because mass timber lends itself to that, it's also because there is an incredible market emerging because the city of Vancouver just approved the Vancouver plan and the Broadway plan, which foresees a lot of lots along our arteries to be rezoned to accommodate 8, 12, 15, 20-story buildings. And the same is happening in Toronto and many other cities in the US as well. So there is a need for that solution. And it's multifamily, it's high-rise, right? So they have similarities. There's a scale to it as well, right? They have 30, 50, 100 units. There's a combination with commercial spaces. So all of that needs to be figured out. And then you have a pretty wide market to serve, right? So then the investment makes sense.
And so are all of your clients developers?
Yes.
Okay. Yeah. So that's another kind of different thing that some firms are totally dealing with developers all the time, and then others are not dealing with developers at all, right? And so it is kind of interesting to think about all of the different pieces that are playing into this with market demands and value proposition, with design, with mass timber, with CL, like with all the things that we've talked about during this episode are really playing into this ecosystem that you've defined that you want to play in. And again, with the focus, it just gives you the ability to continually refine the process and deliver more and more value because you're not distracted by other owner types, other project types. I mean, I can even imagine that you have a pretty limited set of locations that you're decided to go for, at least early on, right? Because of the constraints, and that actually helps you make decisions and develop these tools.
Yeah, absolutely. There's certain jurisdictions, certain cities, and we don't even have to think too much about it because, if you just focused on Toronto, you would have busy. More than enough. Yeah. We could build 1,000 factories in North America. There's just so much demand for housing.
I think it's so interesting that you even say that because, like, I think, again, if somebody listened to this whole episode who's been part of a firm for a long time, and how could we even compete with this? Like, it would be impossible for us to. There's so much work out there. There is, like you just said, if you only focused on Toronto, you would be busy for the rest of your life as one company just solving for that. And I think that's something that keeps coming up, as we talk about the housing needs. I mean, especially with housing, right? Over the next 30 years, it's just that the needs are so big. There is so much work for everyone. And the only way to actually accomplish that is by coming up with systems like these to produce projects at scale, like quantity, right, of units that need to be built over the next 30 years is an insane number. And so there is a lot of work out there, but doesn't mean that it fits the existing business models. And I think that's what you guys have shown success in, is like you've developed a company around this business model. And I'm sure you're open to even adapting that over time as need be. But this is one of those things where it doesn't fit the traditional business model, and that's okay. We're still gonna add value as architects in this space. It's better than not adding value as architects in this space. I can only imagine that these
Yeah.
units are more attractive because of the value of real architectural design.
Yeah, absolutely. Yeah. And my hope is that we will see in the next 10, 20 years an ecosystem of product-oriented companies to emerge. And they could be motivated by prefab, they could be motivated by architecture. They could have it all, right? They could outsource the manufacturing, and there might be an ecosystem of prefab companies that accommodate that, right? That have the technology, just like Foxconn builds the iPhones for Apple, right? Apple doesn't manufacture it
Right.
themselves, but car companies manufacture cars themselves.
Mm-hmm.
But there are all these different business models. I would just hope that there would be an ecosystem of many different products, and they would prove to be better. They would have better quality. They would be faster. They would be more affordable. And so we, in that sense, we welcome competition because it just shows that the model works. And there is enough for many companies like us to come out and develop some kind of product for some kind of market.
Can you speak at all to the idea of risk versus reward in this? Because you're not just playing the role of the designer at the early phase of design, but you're actually doing the production and beyond. So was that an easy decision for Intelligent City to make, to move into those roles, to get a bigger piece of the pie, but also have control over quality and process? I mean, I can see how they're all interwoven, right? It's not like you're doing a handoff. You're not just producing plans for somebody else to build off of. So it's different. But I would assume that also plays a role in kind of the success of this model.
Yeah, there's certainly risk involved in making building components that you have a warranty on, and that those buildings then have to stand the test of time. But it's the counter argument for that, and the reason why we engaged with manufacturing was that we simply didn't see a different way. We didn't see a way to find a different prefab company that could then maybe install robots for us and then make our components. So it would be really difficult to interface with a company like that, and they would come with their own agenda and their own fears and
more bubbles,
goals, right?
more fighting bubbles, right?
Yeah, exactly.
Avoid that, right?
Just the interface of shop drawings is incredibly, just if you ever go through that process as a designer of making shop drawings and then tendering it out and talking to those suppliers and trades, it's so difficult, and so much information gets lost along the way too. So and to some degree, we don't even need to make shop drawings except for the fact that they need to be signed off by an engineer, right? But the data just flows directly through and goes onto the shop floor, and I think it just relieves you so much that you know that there's a team there that knows exactly what to do. So I think that's one reason, and actually the other reason that I can think of right now is also that the technology to make building components like this doesn't exist, and we are in some way also building an industry of prefab technology for mass timber high rise. Like there's lots of machines and equipment out there for stick frame automation, and they have these nailing bridges, right, that kind of put together the stick frame wall, more or less automated, and that's pretty fascinating. But the technology for building assembly lines in mass for mass timber building components doesn't really exist, and so we really needed to think about that ourselves, and even talking to integrators that integrate robotic or automation equipment in factories such as car factories. They themselves also have to rethink when they work with us because of that amount of flexibility and customization that the equipment needs to provide. So we kind of feeling like we're building that industry from scratch that hasn't existed yet. Like in the car industry, there's so many suppliers out there, right, that make parts. And in our industry, that's really not the case. So that was also a realization that we had.
Yeah, this whole idea of everything that you model matters is so true in what you're doing. And because I think, again, kind of one of the biggest disconnects in traditional practice is the people who do care so much about technology and the process, and they're doing real BIM that ends up in sheets of PDFs, and that disconnect that happens right there, that also doesn't exist in the model that you guys have built and implemented, where everything from the early parametric design to the modeling to the algorithms that you use to drive the jointing between the elements, and it goes to the machine, that goes, the machine code to the robot, to the factory floor, to the production, to the fabric, it all matters, right? You're not doing it for a different incentive than a builder. Like so many architects are drawing a set of plans to get a permit, where the builder needs something a little bit different than that, right? If an architect were to go to a builder and say, what do you actually need for the details, right? Versus what they already know how to do, and they're not going to do it based on how you drew it. They're going to do it on how they know to do it. There's so many kind of misaligned incentives in that process. You don't have that in the Intelligent City model.
Yeah. I mean, we are still somewhat connected to that process because we do need to submit permit applications, right? We need a building permit, a development permit. And so you do need to submit, a 400-page PDF or, 17 printed copies to the city hall.
Right.
So that still happens.
Right.
And we're trying to automate that as well in some ways. But the what would you call it? The 3D model, the information model.
Right.
It's called an IM. The one that contains all of it is beyond what you do for BIM. I'm not sure what the exact incentive was to establish BIM, but in most cases when I see it, what I see is still representational geometry, right? It's like the 2D drawing, so representational drawing, and the 3D BIM model is representational 3D model.
Design intent,
Yes, yeah, and it contains, there's a block, and it contains a single geometry that is actually representing multiple layers on a wall, right? Whereas our model that is automatically generated contains all the actual parts. So in some ways, as an example, the drywall, the 4x8 sheet of drywall is its own element, right?
Okay.
It's a part, yeah, exactly. And so that is captured in our model, and including, of course, the metadata that comes with it, identifies what kind of material it is and what kind of product it is, and so on. So it's more than that, and sometimes it's also less than that, because for some of the manufacturing processes, we don't need the geometry. We only need the instructions for the machines, and those might be actually less geometric information than what you would need visually, right? So we don't actually need to model the screw or the nail. We need to model a point that indicates that the robot will put a nail there. So that's different requirements, and so that makes a very interesting 3D model. But yeah, it's kind of ignores what BIM is about in a way, and at the same time, we also then need to make BIM models so that we can collaborate with outside consultants as well. So again, it's sort of an internal process, and it comes with an interface to the outside world.
Yeah. This has been a fascinating conversation. Is there anything that we missed that you want to talk about or to put out there to the audience?
I think we touched on most things. I made a list before before we started.
How very German of you. Yeah.
Things.
Great.
Yeah. No, it's been great.
Awesome. All right. Well, I'm going to include links to everywhere people can follow Intelligent City and you in the show notes for the episode. And thanks so much for having this conversation. It's absolutely fascinating, and I think we'll at some point have to do a round two. I'm hoping that as things are changing so rapidly, I'm sure that everything that's happened in 3 to 4 years that you said, that's going to accelerate. Like, you guys are just going to be at another level in so much less time than that I think we'll definitely want to do a follow-up and see how things have changed in the not too distant future.
Yeah, thanks so much, Evan.
Thank you to Avail for their support of this podcast episode. Visit getavail.com to see their holistic approach to content management today. This show is part of the Gable Media Podcast Network. You can see all the shows at gablemedia.com. That's GABLMEDIA.com. You can help support what I'm doing here by leaving a 5-star review on Apple Podcasts to help get the word out, and of course, share it with your friends. I'd love to hear from you, so leave a comment on the website at trxl.co/podcast, where you can find every episode. You can also follow me on Twitter and Instagram and YouTube. Just search for eTroxel. Talk to you soon.